Thank you and welcome everybody for being here today. And today we'll be first hearing from Professor Nicholas Tyler. He's at the Center for Saami Studies at the University of Tromsø in Norway. And then later we'll be actually hearing from Sara Katrine. And she is actually part of the Saami. And then we will take some questions. And as you said, you will translate for her, Dr. Tyler, if the questions get a little complicated.
That's right.
Thank you so much.
Good morning or good evening, everyone from the far north of Norway, where it is now 10 to 11 at night, and the sun, of course, is blazing down because we are in the land of the midnight sun. I'm going to speak to you about a global problem, which is the shrinking resource base of pastoralism. And I'm not going to go into any detail. I intend only to outline the case, but I hope my talk will encourage you to read the paper on which it is based, which is available to you all. Following my presentation, a reindeer herder, Sara Katrine Alexandersson, is going to present her view of exactly the same issue. The performance of free-living large ungulates, and by performance I mean survival, growth, and fertility, and hence the well-being of pastoralists who depend on them, is modulated by two kinds of drivers. It is modulated by variation in the natural environment, of which climate change is an obvious example. And it is modulated by human intervention, which is independent of environmental factors. And governments and encroachment are obvious examples of that. And these two drivers are generally considered separately. Climate change is very much discussed in ecological literature. Human intervention in pastoral societies is much discussed in geographic and anthropological literature. But of course, the performance of the animals reflects the integrated effect of all the drivers that impinge on them, not just one class. So the aim of this study was to compare the impact of environmental variation and human intervention on an extensive pastoral system. And our model was Saami reindeer herding in Norway. Okay. Reindeer pastoralism is the largest contiguous grazing system in the world. It stretches from Fennoscandia in the west, halfway around the world, through Russia to Far Eastern Siberia. This is an area of some 10 million square kilometers, in which some 2.5 million reindeer are tended by herders from 24 different indigenous peoples. So it's a vast operation. In Fennoscandia, here, this map, you find the Saami people, and they tend to herd about 650,000 reindeer in a transhumant form of pastoralism. Now, the climate of the world is changing, and climate change is considered a major threat to the northern ecosystem. And here in this graph, I hope you can see my mouse, you can see the temperature anomaly of the planet, the globe as a whole in black, and in blue for the Arctic. And the rate of increase in warming is twice the rate of the globe as a whole. However, there are two fundamental considerations. The first is what I call the climate paradox. Organisms do not respond to climate. No organism on the planet responds to climate directly. Organisms respond to the weather that impinges on them and on their resources. And the relationship between large-scale climate and local weather conditions that actually influence the things that people are interested in are neither intuitive nor often examined. That's the first point. The second point is that non-climate factors have an immense role in this, in the modulation of this system. Pastoralism is powerfully modulated by factors that influence, in particular, access to resources. So we looked at the effect of local weather on reindeer pastoralism. This graph shows the mean winter temperature across the northern pastures in Norway over the last 50 years. And the black line shows that there is indeed progressive warming at about a rate of about 0.05 degrees per year. But when you survey the ecological literature, which is what we have done in this paper, you find that warming has both positive and negative effects. I should say that the other way around, has negative but also positive effects on the ecosystem services that affect reindeer. And by that I mean warming in summer and warming in winter. You find positive effects and you find negative effects. Secondly, the weather is temporally and spatially highly variable on both an annual basis and on a decadal basis. And here in this graph, I've marked 3 decades, periods when the weather was significantly warmer than predicted by the general trend, or significantly cooler by the general trend. And this variation, we argue, is likely to alternatively amplify and counter the effects of net warming. And then the third observation we made in the paper is that some trends, on the other hand, are clearly favorable. This graph shows the net trend in the number of days of snow cover in winter, snow being a very important aspect of the ecology of reindeer, and that is decreasing. So the conclusion from the first half of our paper is that it is in fact unclear whether climate change is an important driver of change in Saami reindeer herding at all. So we move on to non-climate factors. This is a map of Norway, and the green part marks the part of Norway which is designated Saami reindeer herding pasture. It's about 40% of the entire land area of the country. And here, the Saami have a right, in principle, to graze their reindeer on uncultivated land, irrespective of land ownership. But this is not an exclusive right. Other users have rights of access to the same land. And there is a suite of problems associated with this. The first is the withdrawal of the legal right to graze. The second is the disruption of access to pasture. And the third is the reduction by human activity of the value of pasture. Take the first one, the withdrawal of grazing rights. This is nicely illustrated by the blocking of transhumance, by the closing of transhumance being the seasonal movement from discrete summer to winter pastures, the migration as it's practiced here. The blocking of transhumance by the closure of international borders. The border with Russia up in the far north of Norway was closed legally in 1826, and then a 200-kilometer fence was completed in 2018. So this is ongoing stuff. The border with Finland, shown in this part of the map, was legally closed in 1852. But since then, a 1,000-kilometer fence has been built, and that was completed in 1952. And then the border with Sweden, which is not shown on this map, was closed in 2005. As I say, this is ongoing stuff. The consequences of these border closures has been a loss of approximately 50% of the traditional winter pasture of Saami reindeer herders in Norway. And also a transformation of the vegetation. And in this photograph, you can see a picture looking across from Norway into Finland. And the border between Norway and Finland is quite clear from the air as a line and change in the vegetation. If you think about it, if you have an ecosystem, a central part of which is the passage of animals from one area to another area, and you think, how can I best disrupt this ecosystem? I tell you what, let's put a fence across the migration path. That must be an effective way to disrupt the system. That is what has been done. Governance is another aspect which influences the rights of herders to their resources. Sami land tenure systems and Sami management institutions are explicitly subordinate to state management. And this graph shows major legislation influencing the practice of reindeer herding since 1751. Each point represents a piece of national legislation which affects what the Sami can do. And there are 3 black points. These are respectively the Reindeer Herding Acts of 1933, which introduced a system of bailiffs to regulate herders' access to pastures, and then subsequently the introduction of a special reindeer police force to assist them. In 1978, there was a regulation of all aspects of reindeer husbandry. It is up to the authorities to decide the division of districts, the allotment of production units, the number of reindeer, and so on. Total state control. And then the 3rd Reindeer Act in 2007 provided a certain amount of self-determination, but this is found to be unworkable. And in the words of one reindeer herder, this is because there are no regulations on how the law should be applied. Not one, and the result is chaos. Another aspect of the same thing is land use planning and encroachment. Grazing rights exist. They are protected, but they are only weakly protected. And herders are obliged to concede land to development. I've made a list here: agriculture, hydroelectricity facilities, linear infrastructure, roads and power lines, military training areas, illustrated by the great base at Porsangamoen here, mining operations, recreational facilities and activity, and wind farms. The law favors the developers, and this we've described in considerable detail in terms of the planning authorities are empowered to rank differential societal considerations. So although the herders have a right to graze, the authorities can say, yes, but this other need is greater than your need, so the development will go ahead. We make the point in the paper that physical losses, like this military base, are actually, in this whole scale of things, small and rather localized. But non-physical losses of pasture, on the other hand, are simply vast. And this is the problem of what we call avoidance behavior, illustrated here by the tendency of animals to avoid infrastructure. And in my little cartoon, there's a house and there are 2 reindeer, and some distance away, there are a load more reindeer. Avoidance is the reduced abundance of animals in the vicinity of infrastructure. It is a behavior which is the animal's own expression of the reduced value of pasture. And it is a very widespread phenomenon. It's been described in 234 species, mammals, birds, fish, insects, including 12 species of large ungulates. Zones of avoidance in reindeer typically are identified as a 50% reduction in the use of pasture between 2.5 to 5 kilometers from infrastructure. And here's another cartoon. You imagine a power line being built, and each mast on the power line sits on a 10 square meter concrete base. Well, if you have a power line that extends for 100 kilometers and you have 4 masts per kilometer, it's easy mathematics to calculate how much ground is physically lost by putting concrete on it. It's not a lot. But if, on the other hand, that power line, reindeer subsequently avoid that power line in a belt some kilometers on either side, within which they use the ground to say 50% of normal usage, the effective loss of pasture is 100,000 times greater. It is simply vast. And if you look at this, the effect of this phenomenon across Norway, here you can see 4 maps of Norway, 1900, 1940, 1994, and 2019. And the green color represents land more than 5 kilometers from infrastructure. And in the middle of the map, you see a little yellow line. Everything north of that yellow line is reindeer herding. And we calculate that across the last 120 years, there has been a 71% reduction in the area of undisturbed pasture. And a corollary of that is if the animals are using this land near infrastructure less, there's going to be a 29%, an increased grazing pressure within the remaining 25 and 29% of undisturbed land. So the conclusions from our paper is that the principal determinants of the development of reindeer husbandry are the loss of pasture to infrastructure and administrative encroachment that erodes herders' freedom of action. And these, we say, simply dwarf the effects of current climate change on the system. And finally, I will say that what I've described here, the relationship between climate variation on one hand and human intervention on the other, is not unique to reindeer husbandry. Legal, administrative, the impact of administrative, economic, legal, and social constraints is a problem in extensive pastoral grazing systems across the globe. And in the paper we've given examples from 23 countries where you see exactly the same phenomenon. There you are. That's what I've got to say. Thank you very much for your attention. And there's the DOI of the paper, if anybody would like to read it. Thank you.